let's get to talk about the photoelectric effect. So, photoelectric effect involves emission of electrons. So, we have emission of electrons from a metal surface when light gets to strike. So, when you have a metal surface and then you have light striking this metal surface like that. So, emission of electrons is what we are defining to be the photoelectric effect. So we've seen that there is first of all light striking, and then we are seeing the emission of electrons. So emission of electrons from that metal surface is what we are calling the photoelectric effect. Okay, so there are a few things that you'd have to know about photoelectric effect. Okay, that gets to govern how much of the electrons are being emitted from that metal surface. Okay, so the first thing that you'd have to know is you can take down this. This is very important. No electron emission. So there's no electron emission. So write this in full form: no electron emission below the threshold frequency. So threshold. So there's threshold frequency. So there are no electron emission below threshold frequency. So there's the new term called threshold frequency. So you need to know that the threshold frequency is the minimum frequency required for electrons to be emitted. So you understand that before electrons can be emitted from a metal surface, there is certain amount of energy that is required to kind of unbind them from, because they are attached. So there's need for energy required to remove them. So that energy is what we are calling the threshold frequency. Okay. Of course, we understand that the formula itself is that. So the energy requires a certain minimum of frequency. So that's what we're calling the threshold frequency. Threshold frequency is a minimum frequency required to emit electrons. So the first point that we are noting about photoelectric effect is no electron emission below threshold frequency. So when you are striking a metal surface with a light with lower frequency or frequency below the threshold frequency, there will be no emission of electrons expected from that metal surface. That is the first point. The second point is the amount of electrons emitted above the threshold frequency. So I'll go again. The amount of electrons emitted above, so the amount of electrons, so I can say emitted above the threshold frequency are directly proportional to the intensity of the light. So I believe you understand the intensity of light. When light has got high intensity and low intensity. So what this tells us is if the light that you are using has already more than the threshold frequency, as you begin to increase its intensity, you expect that more electrons will also be produced. So increasing the intensity when a light has already met the threshold frequency increases the amount of electrons being emitted, and vice versa. If you reduce the intensity, okay, despite the light being above the threshold frequency, you expect the number of electrons being emitted will also be reduced. And then the other point, the third point under the photoelectric effect is that an increase in the intensity of light, so an increase in the intensity, so you can also decide to increase the intensity. when the threshold frequency is not met. So an increase in the intensity of light below the threshold frequency does not produce any electrons. Okay? So whether you get to increase the intensity of the light, provided the threshold frequency is not met or it is below the threshold frequency, there is no emission of electrons, even as you get to increase the intensity of that light. Okay. Then finally, the thing that you'd have to note is number 4, that is number 4. For the frequency above, so for the frequency that is above the threshold frequency, the kinetic energy of the electrons gets to increase with the frequency. I believe you understand what that means. So that will introduce us to a formula that is very important when it comes to determining the kinetic energy of the electrons that are emitted from a metal surface due to photoelectric effect. So the kinetic energy of the electrons emitted is given as a difference between, so I'll explain this formula. So this part here is representing the threshold. So the V naught there is the threshold frequency. So threshold frequency will be able to give us the amount of energy required to remove those electrons from the metal surface. So I was talking about unbinding of the electrons. So that unbinding requires a certain threshold frequency. So we subtract that energy from the frequency of the electrons. Okay? So the frequency of the electrons after emission minus the initial gives us the difference is the energy, the kinetic energy, or the energy that is leading to the motion of those particles. Of course, understand that h is the Planck's constant, which is 6.626 by 10 to the power negative 84. So in a case where they give you the kinetic energy and ask you to find the frequency of the light after emission, you can substitute, provided they give you the threshold frequency. And of course, in a case where they give you the final frequency and also the kinetic energy, you're also able to find the threshold frequency. Or in a case where they ask you to find the kinetic energy of electrons after emission, given the final frequency and the threshold frequency, you should be able to use this formula and apply it. It's very useful, very applicable under the study of photoelectric effect. And of course, this summarizes everything that you have to know under photoelectric effect.